Hey coders, how's it going guys? So today actually we're going to be going through maximum subarray. So this is also one of the popular questions. So we are told that we are given integer array nums and we need to find subarray which has the largest sum and we need to return its sum. So you can think of this question as like they're asking you if you're given an array like so, find the sequence of number that has the largest sum, or find a number rather, even if it's a number, it's still okay. So in this case, if we were about to take 4 up until 1, this will actually give us 6. So this is the maximum sub array. So if you will take these other numbers, they wouldn't actually give you the maximum that is greater than 6. Okay, so for instance, let's get into too much detail. So let's say you will take 2, right? This is negative 2. So and you have 1 here, so 1 is greater than negative 2, so you will discard this. You don't want it. Even if you are about to take minus 2 and add it with 1, you will still get negative 1. So negative 1 is not greater than 1, so you cancel this. So your global will be 1 at this point. That's your maximum so far. You come across 3 minus 3, you take your minus 1 and you subtract it with minus 3, right? Because of, there's negative there, then you're gonna get negative 2. So you don't want this because your global is still 1. That's your maximum sum so far, right? So as you continue, you have 4 is greater than 1, so you're gonna cancel the global, you're gonna update it with 4, right? So you continue, you say, okay, let's take 4 and we add it with negative 1. So this is going to give you 3, okay? And you take 2, you add it into this. This is going to give you 5. So you cancel 4, you keep 5 because of you find something greater. Then you add 1, which is also something greater. Then you're going to add plus 1, which is going to be 6, right? You come through negative 5. Now you realize that actually if you're about to take that 6 and you minus 5, you're gonna get 1. So it's not necessarily gonna give you a maximum sum. So even if you come here, you add 5, it's gonna give you 5, but it's not necessarily maximum sum. So that's how I explain it. I hope you guys were able to get a better perspective of what they want us to do. Okay, so we have these numbers. I've written them down here just so that we can get a few ideas how we can go about this. One way we can go about this is that, okay, we can say, how about we have a for loop which is going to start here, right? So we can have a for loop. So for I, from I in range of n minus 1, right? So we can start from here, but we know that we want to get also a sum from these numbers going there. So we can also do that. So we can say for j in range, right, in range n minus 1. So this essentially will make sure that if we are here 2, we can sum 1, we can sum 3, we can sum 4, but we're going to need the final for loop. The final for loop is the one that is actually going to help us to sum this, and we're going to have to keep track of the sum. So this is one way we can go about it, but this solution is going to be n cube, so it's not so much efficient, okay? But we can maybe try to make it efficient if we remove an outer for loop. So if we say, how about then we keep track of the current sum. For instance, if we sum this, we say, okay, max sum from I to j, we add these two, this is going to give us negative 1. That's our current sum. Then we go to minus 2, we push j to 3 now. So we say minus 2 minus 3, this is going to give us what? But we can't jump 1 just like that. So we need to make sure that we maintain the sequence. So that's another thing that you should keep in mind as with this for loop. but this solution will take us to n squared solution. Okay, so can we also do better? Yes, we can. So we're gonna use what is known as a Kadane algorithm. So Kadane algorithm essentially help us to solve this problem in O of n time. So guys, the main idea behind Kadane's algorithm is that, for me, the key takeaway is that we need to keep track of the sum as we continue through the array. And the second thing is that we also need to keep track of the current element sum, because it can happen that as we iterate, right? But these numbers that we have accumulated so far, they are not actually greater than the current sum, right? So we always need to check what the sum of the current sum is and what's the sum of the accumulated sum from the array that we've been. So, and the third thing is that we need to keep track of all the accumulated sum as we go on. But the point here is that if we store the current element, because we're going to start at 0. So let's say we start at current element and we store -2, right? So, and our for loop for I in range of n, and our for loop start at 1, okay? So what we can say is that we can say we want to take the max of the current value, which is -2, right? The current value plus 1, which is element at I, element nums I, or we just want to keep nums I because the current element could be greater. So what we're saying is that we're saying is this number added with this, what is their sum, right? Their sum here in this case is going to be -1. And what is the sum of the current value? The sum of the current value is 1. So what means that we need to take 1 because that is the maximum sum so far we have seen. So we're going to cancel this current sum and we're going to replace it with 1. And also the global, remember that this is what we need to return. So the global is so far is 1. We move to the next array. We move to the next number. We find that we have -3. Okay, so we say -3 here is going to be the current nums, which is -3. We say the current num, which is 1, and we add the current number, which is -3. What does this guys was? So we have something like -3, and this, if we add these two, we're going to get -2. So the current nums is going to be -2. Okay, we continue with our array. We say, okay, cool, what is 4? You can see that I'm keeping track of this -2 because we don't know if we might add something greater that is actually gonna make this number greater than 1. Hence we need to keep this -2 also. So we go to our next number, which is 4. So similarly, we put 4 as our current number here. We take 4, we say 4 and the current number, which is -2. What is greater? So we know that 4 is actually greater, right? So this is going to give us negative. So we override our current with 4. And the largest that we have seen so far, what is it? It's 4. So at global, this is what we might return. So, okay, 4 is there. We move our iteration. We come here. We say the current number is -1. So we're going to take -1 and we're going to add it with 4. So then this is going to give us 3. So we say the current value here is 3. And we don't have to update our global because 3 is not greater than 4. Okay, but we keep 3. We come here, we ask ourselves, is 2, we take the 2, we put it here, right? This is our current 2, this is our current value, and we take 2 and we add it with 3 because 3 was our large number. So we add 3 plus 2 is going to give us 5. This is going to be our current value, and 5 is also going to be overwriting the global because that is the largest that we have seen so far. Okay, we move to our next number, which is 1, right? So we still have 5 as our current, and as our current val, then the number that we currently iterating on is 1. Then we know that 1 plus 5 plus 1 is 6, and this one is not greater than 6. Then we're gonna make our current to be 6, and 6 is the greatest number that we've seen so far. So it's gonna be the global what we need to return. We move to negative 5, okay? Then we take 6, which is our current, and we subtract it with the current number, which is negative 5. Then this is gonna give us 1. And what is the current number? Is negative 5. So we need to update the current val with 1, because that is the maximum val. 1 is not greater than 6, so we won't update the global. We get 4. What do we do when we get 4? Similar thing, we say the current val is 1, we're gonna add 4 is gonna be 5, then the current num is 4, so we need to keep 4 here. So we don't update because 4 is not greater than 6. We need to return 6, and that's how they were able to get this output here, 6 in linear time. But one thing that you can see that we're doing is that we're literally keeping track of the maximum number as we go on. It's like if these numbers from going backwards, they give us like negative 1, for instance, why not keep 4 as we're going forward? We don't need them because they're just small. They wouldn't make any difference. So that's what we're doing, is like we're keeping track of the number that we accumulate. And if it happens that the number that as we accumulate this number, and there's a number that is greater than the previous array added together, we're gonna keep this, because it does not make sense to keep this if this is giving us negative 3 and this is giving us 2. So hence we need to keep this. And global, this is just to keep track of the maximum. It's like now we see if we get 2 and we come here we get 4. So it's just going to keep track of the maximum. Then the current val is just keeping track of this local max values that we have here. Okay, so that's like the solution. And yeah, let's go and code it up now, guys. So let's code this one up, guys. So what I'm gonna do is that I'm gonna have global. It's gonna be global nums. So like I said, the first thing that I would like to do is that I want to keep track of the first element. So we can think of now I'm taking -2 because that's the first number that we see, right? We don't know if it's greater, so that's why we have to keep it. So I'm gonna call this current val. So current val is gonna also be nums equals to the first element. Okay, so which means that when we iterate, we need to start from the second element. So it's gonna be 1 up to the nums, the length of nums. Okay, I'm gonna do that. Then what we need to do here is that I'm gonna say current val equals to the maximum of current val. So here we just need to make sure that we take the current element and current val and we add it with the current element that we're iterating on. So it's going to be I. Then we take, if it happens that the current element is actually greater, we're going to take that one. Okay, then what I'm going to do is that I'm going to ask if the current val, right, if the current val is greater than the global nums. So if it happens, I'm just going to update the global nums. Okay, so it's just going to be global if, I think I forgot an if there, if this, then I just want to make global nums is to be current val, right? Then we're just gonna return global nums because that's what keeps track. So that's let me check if it's working. I did not make silly mistakes, and it works. So the point here, just to walk you through the code, is that we're keeping track of the first, we take the first one, then we go to the second number and we ask ourselves, taking the first number, which is -2, when we add it with 1, does this mean that it's This added that 2, and does this mean that it's greater than the current element, which is -1, which is not. So we're going to take -1 as our current, and the current is actually going to update the global because the global had -2, so this is going to be -1. Okay, then we continue, we go to -3 like I showed you in the slide. Just go to -3 and we do the same thing as we've been doing. So yeah, I'm gonna, so this it's a linear solution, so it's better than the ones that I spoke about, which had a quadrat, what is it, exponential time. So thanks guys for tuning in.